I'd now like to welcome our next speaker, talking about blockchain for shipping, onto the stage, Deanna MacDonald. Deanna is the co-founder and CEO of BLOC, Blockchain Labs for Open Collaboration, a digital solutions provider which is for the energy and maritime sectors. And as an industry practitioner, Deanna has over a decade of experience with the global trade, energy, health, and finance sectors in developing, applying, and scaling technology, and an academic professional background in governance and inclusive participation in defining the needs of technology. So please welcome onto stage Deanna.
Hello, everybody, and thank you for the introduction. So yes, my name is Deanna, and I come from an organization called Blockchain Labs for Open Collaboration, and we are located in Copenhagen as well as in other areas such as Singapore. We have been doing a lot of work here in London and in DC as well. And we work primarily with blockchain, but blockchain is a component of many different technical systems that need to be implemented to create secure and resilient digital infrastructure for the new era and the new age. And with that being said, I'm here today to speak about not just blockchain. I'll give a brief introduction to that. I won't dive too deep into it. And I will not be telling you about what crypto to invest in. That's not our game. And I will be also applying it so we can work with something a bit more tangible than the high affluenting kind of silver bullet approach that is normally taken within this space. I'm not sure if those of you are aware of any of the media around blockchain, but so far it's been used for everything under the sun and has fixed all of the world's problems. But instead we'll look at it in a very practical way and how we can utilize it. But I'll also be talking about our recent funding partnership together with Lloyd's Register Foundation, wherein we'll be utilizing and employing blockchain as a part of a solution to creating resilient digital infrastructure within health and safety and risk of engineered systems. And then I want to follow up with talking about our new collaboration models, how we organize that, how we build this technology, how we source it from the industry, and how we build upon the expertise that the industry provides, and together with industry and technological practitioners, how we see this technology being built and deployed. So that's essentially where I'll be coming from today. So we'll go through kind of the 101 to what is blockchain. So essentially, it can be brought down to its core elements. Blockchain itself isn't necessarily a new type of technology. Rather, it's a bunch of technologies put together. It's a bunch of IT systems and components of technologies. What's really innovative is how they're sutured together to create a holistic system or a global protocol for communications. That being said, when the birth of the internet happened, what we witnessed predominantly was a protocol, a communications protocol that allowed us to talk from one system to the next. The innovation within blockchain is exactly that as well. It's a protocol that allows us from one system to another to be able to validate these communications and these transactions. And in that respect, it's just simply, to simplify it really down to its core essence, is just that we are taking digital ledgers, such as Excel files, or ledgers that we currently already have that exists, and we're essentially cryptographically securing them and then replicating them and sending them out to a bunch of different servers, different hosts in the network that each retain a copy of this ledger. This ledger can be recording transactions, such as in the case of cryptocurrency, or it could be recording data or information or exchange, anything that you would normally record in a ledger. That being said, from the time it is copied and transferred and stored in all of these different computers, the protocols that are used to create consensus among these nodes in the network is what validates that information hasn't been tampered with. So essentially, when you host a record of something on your system and someone else holds it on their system, you would have to hack into both of our systems at the same time and change the same record. And furthermore, every single other host on that network as well. So what's really innovative about the fact that this is stored on so many different computers and nodes in the world is that it becomes tamper-proof in the sense of very difficult to break into, and furthermore, it's cryptographically secured. So there's two types of security breaches that would have to be imposed to be able to change the information inside these ledgers. And lastly, it's the consensus algorithms, or these protocols that I've been talking about, that validate that these transactions are in fact still continuing to be consistent among the network. And in that respect, that's really all blockchain is. And it's not the the storage solution for everything as of yet. We haven't been storing information on the blockchain. We've been just utilizing the protocol on top of how we're already storing information to validate and verify that information exists. Likewise, it is not predictive. It doesn't have analysis built in. That's the combination with machine learning and AI and data science and analytics that would require that. So I just wanted to break it down as a fundamental component of its core functions here. And I want to start with that as a premise so that we can kind of talk about how to apply those elements. And more to the point, what these elements actually create is just basically, I would say, three really innovative, or at the very least, three very useful properties for us. One is that we can timestamp something to have happened. And that means that we can say that this exchange of data or information happened at this time, and when that is timestamped, that's held inside of the ledger and the record as well. So now we have a chain of custody as to the existence of something happening and where and when it did happen. Secondly, we have this immutable ledger where we can at least verify that the information we've put into the system, whether that's true or not requires us to put that in there and be truth, but we can verify whether that information is true or has been tampered with. And lastly, it creates the interoperability between systems, to be allowing these systems to communicate to each other and to do so in a consensus. So, blockchain and shipping, where are we at? I don't know if you've heard in the news recently there's been a few what are called initial coin offerings, and that's what the terminology you'll see up there is ICO. What that is a basic new way of crowdfunding based on cryptocurrency. It's currently not regulated and steps outside and ignores a lot of regulations, so inherently there are some accountability issues associated with it. But that being said, ICOs are a new way to raise funds. That's been happening in the maritime industry, but that's not to be confused with the fact that that's not necessarily building a solution, that is just fundraising to build a solution. So while it seems like there is a lot of activity in this space, in fact there is not. Too many, at least, real-world examples. And we've spent the last year doing a feasibility study sponsored by the Danish Maritime Fund to how and where and, if possible, do we apply blockchain in the shipping industry. And furthermore, what systems can we leverage? What have people been building? How do we create collaboration within these? Primarily, our findings are that there are very few real-world examples. There are very few examples that are bridging the digital and the physical, and furthermore, that are outside of the simulation environment. So with that being said, we've kind of analyzed the market in terms of the different solutions, whether they're on what type of systems. So some systems are open, permissioned in public, or permissionless in public, which means anybody can submit information, anybody can see transparently that information. There are other systems that are more private and permissioned, which means that you have to have permission as an actor in the network to view the transactions or the exchanges that are happening. And in that respect, what we've come up with and the main findings that we have and that where we are coming from in our partnership together with the foundation is that there is truly a lack of interoperability between these systems. What is one myth is that there is the blockchain, but in fact there are several. There are tens, if not 20 or hundreds at this point in time of types of blockchains. There are competing systems that are emerging and the functionalities of these systems are now becoming evident, but it's still such an emerging technology. The problem being that these systems are competing with each other rather than creating interoperability between each other. So the unique property of blockchain isn't unique unless one system or a compilation of these systems that are working together are implemented. So as it stands, we're in fact not creating that new kind of decentralized network that allows actors to participate and communicate equally. Secondly, we do not have a lot of industry collaboration. We have still isolated technological development wherein these systems are being designed behind a computer and not necessarily in conjunction with the problems and the needs of the industry, not inclusively and not with engagement and participation. And lastly, we are finding that there is very few real-world examples that we can actually utilize, and furthermore that the technology is so nascent that if we are to utilize it, we need to do so in an open and transparent way and teach best practices and lessons learned and facilitate and communicate between the practitioners ourselves. So with that being said, we are looking to launch our first demonstrator. So a part of our partnership with the Lloyd's Register Foundation is that we will, over the duration of 18 months, conduct and build 3 pilot use cases for blockchain within maritime and specifically addressing the risk and safety of engineered systems. So with that being said, we are also going to utilize our learnings and our lessons and our business models associated with it and the builds that we make to be then educating the community and educating the industry and furthermore educating us as practitioners, and doing so openly and collaboratively. And so those are our mandates. And with that being said, we investigate our demonstrators based on industry engagement, based on the needs that we are sourcing from the industry that fit within the mission of what we're looking to build, but furthermore that are validated by the industry itself. So we host a series of workshops. We're currently on the first demonstrator, and we've hosted about 3 or 4. We've just gotten finished with our last workshop in Singapore, and we'll be looking to do the second and the third demonstrator based on our crowdsourcing. So that is always an option. Please reach out if you have ideas around how we should and what we should build on. But the first one is that we are working within the context of the report that was launched by Lloyd last year as well, by very astute assessment, very pragmatic as well, which is one of the reasons we chose to approach Lloyd's Register Foundation in terms of how to conquer this in terms of its critical infrastructure. That's what we work with as well, is securing critical infrastructure, making it accessible, making it cyber secure, and furthermore making it a global system. So we want to, in the 3 demonstrators that we're setting up, we'll launch the first one next month. That one will be likely around, provided it's approved and provided we finish up our research and do a few more iterations on our design. But I wanted to soft launch it here at the Lloyd's Register Foundation conference, which is only makes sense, but also to open it up for peer review and critique, and just furthermore to let you know what we're doing, what we're thinking of doing. And that's to tackle the assurance of fuel supply, of marine fuel supply. And often this is the major problems with the marine fuel supply chain, is that there are problems with the heavy fuels used, with the catalytic fines associated, and they lead to engine failures and furthermore engine problems. There are a lack of data or transparency or chain of custody on any of this information. Bunker delivery notes, which verify that bunkers are sent and received, are done in a paper process, manual process. 1% of the world's fuel is double spent and is essentially fraudulent and being used, being agreed upon in these manual processes as a way to create the next retirement fund for anybody that's taking the fuel. And we don't have any metering or any kind of digitization in that process as well. So how can we create a chain of custody around the fuel supply chain? How can we create quality and quantity assurance and utilize that as a way for shipping operators to provide that assurance that when they charter their ship, for example, they know that the fuel used isn't going to ruin their engines. Furthermore, when we do move over to sustainable fuels, that we can embed compliance within this. We can test these fuels and know that their sulfur content is within limits, that the catalytic fines are within limits, or furthermore that they are we know exactly what their emissions are, and we can then later report on those. So we're looking up this is the supply chain and the value chain that we're working on. So how can we bring tests right now? We don't have any quality tests being done upstream. We only, in fact, have a quantity measurement taken by a mass flow meter only in Singapore, and in other ports there isn't even one. There's the density measurements that are taken in a non-best practice way that is changed upon terminal to terminal. So we want to move these tests around. We want to then take these tests and we want to create a digital record that is immutable and a chain of custody associated with these tests. So if we can take a quality test by the different suppliers that are bringing their fuel to the terminal, and from there, create a record of that links back to the blockchain, which is then a cryptographic and secure record that points to the tests that have been done. We can evaluate as the tests are taken throughout the supply chain, and furthermore, as the fuel is exchanged throughout the supply chain, when there's a discrepancy between the fuel. When it's blended, has it been tampered with? Is there a discrepancy in what has been said to be claimed or bought or received? And furthermore, we could even get into settlements later on, brokering of bunkers. But as it stands, it's such a complex problem that we just moved upstream into taking it to the point of it being bought. This will allow for better decision-making amongst the buyers as well, to choose their suppliers in accordance with the assured fuel and the chain of custody associated with said fuel, which could lead to reduction in insurance, for example, and premiums, as well as many different opportunities and business cases that we're exploring together with our partners. So essentially, this is how we envision this and our current setup for how we see this happening. So what blockchain we use and how we design this system will be according to the problems that we're generating here, the way that we've set up this this value chain and how we can reorganize it. So whether or not the technology fits to solve the problem rather than looking at the technology as the solution. So how we decide to do this and what we believe is the way to create this technology and to be able to create technology in general within the maritime industry and any other sector for that matter is to do so with a good governance structure that allows us to not only create the legitimacy around our projects, to be able to source the expertise from our partners, and to be able to utilize their operations and their sister companies, such in the case with Lloyd's Register Foundation and their sister company, or their commercial arm, the Lloyd's Register Group. We're working with the fuel testing team, for example, in this first pilot. But in that respect, what we have proposed and how we are to build this is to bring together maximum 4 steering partners that will co-fund and co-lead this initiative. So they will be the ones that approve the projects before we build them and before we start, and that they are therefore ensuring that we are building something that they believe is necessary, that is solving the problems, and we create the governance structure in that sense. But furthermore, that they are able to appropriate and lead us to new resources that we can use in operation, as well as our industry consortia that we build on each of our demonstrators. And from there, we can utilize our external advisors, and we bring in several suppliers for each of these challenges that we're addressing based on the technology. So as always, it's not just blockchain. We are working with a bunker metric system that uses AIS data, for example, to validate and be an external validator as to when ships are docking and how long they're spending in the terminals. We would need to get on board with the current legacy systems and IT systems that are being used in the maritime industry to make our solution interoperable with that. We furthermore might not be using an open and public blockchain, maybe it is a permissioned one, so we have to find partners that are building those types of solutions. So what we do essentially is first identify the problem, have it approved by and furthermore vetted by the industry itself, as sourced by the industry and then approved by the industry. And from there we create collaborations and partnerships from our different actors in the industry that represent stakeholders in that value chain that we're attacking or that we're trying to solve challenges in, and we utilize them to help create this. So we've moved upstream in the development process of technology, but furthermore, we've also integrated our users into the design and into the inclusion of creating this for their own, to solve their own challenges. And in that respect, we're able to create adoption and actually make sure that we are, in effect, designing systems that will be used rather than just designing them for their own sake. And this is how we believe we can bridge the digital and the physical gap and actually provide an invisible digital infrastructure that's secure for the maritime space. So essentially our timeline here is that we are project scoping and creating the consortia around the problems that we're trying to solve right now, which is the assurance of the fuel supply chain in our first demonstrator, and from there we'll build demonstrators and start sourcing them with our workshops that we'll start setting up in advance of the second and third launch of our demonstrators. And we're also workshopping and doing talks and furthermore creating training sessions and education around our learnings and how we're building. And we're creating open forums and plenum sessions and best practice and focus groups for practitioners themselves, as well as for industry actors to come and learn about what we're doing and about the technologies that we're using. And that's all starting now. So we are to launch next month our first demonstrator. And from there we'll use approximately 4 to 6 months to build that and test that. And then we'll be able to iterate on that going forward, because actually we don't know what it's like to apply this in the industrial world or industrial setting. So we hope to be able to document and get faster and better as we go as well. So with that being said, I would like to open up the floor to questions. I like to leave a little bit more time than normally with talks, because this is such an open field right now that has a lot of questions and a lot of hype and a lot of mystery around it. But secondly as well, to have any feedback and to open this up to any suggestions and questions that you may have.
Thank you very much, Deanna. I know a lot of people have talked about blockchain, but for me, seeing it come to life in the example you've given was just fascinating. And that kind of idea of co-creation with the customers and real client problems and forming that collaborative network, I think is a really exciting way to go. And I'm sure there's lots of questions for you. So who would like to start with questions for Deanna? Just over here.
Hi, Deanna. Thanks very much for your talk. My name's John Elliott. I'm from the UK Government's Office for Product Safety and Standards. And a couple of things that we hold policy for or regulate are conflict minerals and rare timbers. So they sort of lend themselves to a distributed ledger, I would have thought. One of the things that we've been thinking about is once something is on the ledger and the ledger is secure and you have confidence in the technology, then hopefully, to kind of phrase it's rather plain sailing. But we're very interested in kind of products leaking into the ledger at the start. So the ledger only being as secure as, you know, when you take something out of the ground and then enter it onto the ledger. And I'd be interested to hear your thoughts on how you either use this technology or other types of technology to crack that problem so that you make sure that things aren't getting onto the ledger at the start of the process.
It's a very good question. That question revolves a lot around what we call the garbage in, garbage out problem. So if you put in erroneous data into a blockchain and you can't change it, it doesn't mean that it's the truth, and blockchain doesn't identify what truth is. It just lets you know that everybody else is storing that same truth or lie. That being said, so how do you verify the inputs into this system? It's tricky because in many ways we're relying on IoT and sensoring devices. And in that respect, you actually have to secure that information flow as well, because our IoT is not secure in any way, shape, or form. So if that's the case, so in the case I can use practically just to bring it back to the meters that we would be using within the measurement and quantity, the mass flow meters in fuel delivery. So then we need to be able to securely take that data from that system in a manual or in a digital process. And in cases where there aren't, I mean, how do you take a sensor for minerals, for example, and make sure that it exists? A lot of work is going on in terms of documentation with photographic evidence. When it comes to, like, for example, forestry and timber, you can do satellite imagery, and that can be a part of the composite, validation of the data put in. Another methodology that we're exploring and that I've seen applied is thresholds as well. So, generally speaking, how much this mine can produce, and you can utilize that as a measurement of the goods flowing into the system. But that is a really interesting area wherein, yeah, fine, we have this system that now can validate what we have in it, but it is the last mile, and it always will be the last mile as to how you secure the information going in. So that's where you have to start first and foremost, and that's the advice I'd give, is that's where to spend a lot of the time before throwing it into a blockchain. That'll always exist.
Any other questions? Sorry. Did I see one over there as well? Just one there. And did I see another one? Just checking. Yes, thank you. Yeah.
Thank you for that. I'm going to take the question or the comment that was just made and try to connect it to the excellent question from earlier from our friend over there about mining and so on of minerals. So if we get to the end of this if we imagine some kind of end of a process, right, in 20 years' time, and this has come to, it's worked, well done, job done, tick a box. Who is better off at the end of this process, and who is worse off at the end of this process?
Another good question. Good socioeconomic questions today. I like it. I think that depends largely on how we design these systems and these networks and what we account for in the design. So my co-founder and colleague Martha would say it's not by default, it's by design. And in that respect, how do we build these systems to make sure that the right incentives are a part of them to encourage voluntary adoption, but furthermore to encourage, the take-up of these. So in the case of conservation, in the case of tracking and tracing of our commodities and goods, how do we make sure that there is an incentive for someone to register themselves or the activities that they're creating, because pushing that system on them will still result in as many errors as we already have, and furthermore, the incentive to lie. So when it comes to actually as well in safety, it's a matter of the people and the reputation systems that you can create within this. So when it comes to, for example, contract workers in the maritime space that are utilizing or that are handing off and trading off things, we are able to say, okay, this person made a dispute about the fuel, for example. Now that's associated with their record, and the contractor now, the employer now can see that. I think that's one mechanism, as long as you can validate and get that system legitimatized in the industry in whatever value chain you're working with. And that requires a lot of political willpower. So you need to have the right governments and systems in place that acknowledge that the information or that the system is good. But I would bring it up to identity and reputations and incentives. And that is something that you have to collaboratively design as well. It's cross-sector and cross academia as well. So game theory and political economy combined with the incentives and de-incentives. And so that's what's really cool about this space as well, is it's mass collaboration because it needs to be. It's not just designing a technical system that everybody should use. It's actually trying to build a better one that is allowing us all to participate.
Thank you. There's a question just in the middle there.
Hi, I work on infrastructure systems research at University College London. So you mentioned it requires simultaneous tampering with multiple cryptographically secured nodes. Are those nodes independent? So the resilience point, with the banking crisis, we felt that we needed an 8% default rate on mortgages for what occurred to occur, and we'd assume they were independent. Is the assumption that these nodes are independent a better assumption than that example?
It is not, in fact. I would say, one, it depends on exactly what blockchain you're talking about, and that is one of the first and foremost departure points, because not all blockchains are created equal. We're finding, the MIT Digital Media Lab has been doing a lot of these studies on whether or not these networks are in fact decentralized or centralized. And it's being shown that quite a lot of them that come out and say we're a blockchain and the nodes are equal, they are each cryptographically secured and your information is stored in a safe and sovereign way. In fact, it's not. They can close the fist, close your wallets on the other end of it, and they have complete control over the system. So first and foremost, I can't make a blanket statement. I can say that the Bitcoin network is the only secure network with cryptographically secure nodes in it. And it's the only one designed as such that has been validated in the last 10 years as not having once been hacked or been breached. That being said, there's an extensive amount of environmental concern and energy required due to the protocol requiring energy. But that aside, that has still proven to be that we can collude on the network as well. So even if you do have cryptographically secure and sovereign network design, you can still have actors that come together to create a 51% attack and override, on a consensus level, override the system. So double-edged sword no matter how you put it. But that's the lessons that we continuously get to learn and iterate on. And the cool thing as well is this is open for people to contribute and design. And all of this technology, at least the ones that we work with, rest on open source foundations. And as such, you're able to kind of continuously improve. And lastly, the incentives built into these systems, again, to backtrack to the incentives and to the life cycle analysis of this, is to essentially penalize any malicious acts and to furthermore get paid in or get rewarded in the currency or the network currency that is utilized. So in Bitcoin's case, miners, which are some of these nodes that we're speaking of here, they get paid in Bitcoin to mine these, to use their heavy computational power. As such, they have interest to keep that system alive and to ensure that it continues to prosper, because that's where their vested interests and investments lie. So it's a combination, again, of design, of network design, but furthermore, to first and foremost say that no two networks are the same in this space right now at all.
Thank you. I'm sure we could continue this debate for a long time, but sadly we've come to the end, and I'm sure it'll be a conversation, though, that will continue during the break and for the rest of the conference. So I'd just like to say thank you very much, Deanna.
Thank you.